another example of horizontal launch. This time we're going to have a baseball pitcher throw a baseball, and as it approaches home plate, it's going to drop, and we don't know how far it drops. So let's read the question here. A baseball pitcher throws a fastball horizontally at a speed of 42 meters per second, ignoring air resistance. Okay, so ignoring air resistance, that's good, because that means we're going to be in, the only thing acting on is gravity, and we'll be in free fall. How far does the ball drop between the pitcher's mound and home plate? 60 feet, 6 inches away. So we're also going to make the assumption that the distance that it goes is from when it leaves the pitcher's hand until it gets to home plate. We're going to say that's 60 feet, 6 inches. All right, so 60 feet, 6 inches is 60.5 feet. I can't keep this as feet, so the first thing I'm going to want to do here is change this to meters. So 18.4404 meters. Now, what type of problem do I have? So as that ball is moving, it's moving in both the X direction and the Y direction. So I have 2D motion, so I have to set up my list of variables. Initially, it's throwing horizontally. So horizontal launch, okay, I know that my initial velocity in the X direction is the initial velocity. In this case, it's 42 meters per second. And the initial velocity in the Y direction is 0 because it's initially not moving up or down. So in this case, I can say this is 42 meters per second. We're ignoring air resistance. That means as soon as that ball leaves that pitcher's hand, it's only under the influence of gravity. So that means it's projectile motion. It's moving in the X, free fall in the Y. So I can say that my acceleration is 0 in the X direction, negative 9.8 meters per second squared in the Y direction. Whenever I have an acceleration of 0, I automatically know the initial and final velocities are the same. I also know that I'm going to be using equation number 2. All right, so that's kind of awesome. So I have all this information down. I now need to identify my coordinate system. So I need to choose where is height 0. Now we usually choose height 0 at the ground, but in this case I'm going to choose it at the lower of the two positions because I don't know how high above the ground this was or how high above the ground this is. So I just want to get the ground out of the situation. So I'll choose this as a height of 0. And I'll choose this as where X equals 0. So this here is my origin. And so it starts at some height, which is Y naught. That's what I want to find, because if I can find that height, that's how far it has dropped, okay? And I know this final X position is this 18.44. So let's fill that information in. So I have an initial X position of 0, a final of 18.4404. Make sure you use all those digits. I believe that's all of them. And then the initial height, I don't know that, and I do know the final height is 0. If you choose the initial height as 0, you'll get a negative final height, and that'll kind of also indicate that it's dropped that far. Okay, so let's kind of set this up and think about what we did last problem. All right, so I want to figure out how far it's dropped. Why not? But I have 3 unknowns over here. Well, I can't solve it. I need one more. So what that means is I'm going to need to find time in the other direction. This is going to be a mantra for you. Find time in the other direction, because that's typically what we're going to need to do. This is going to be our link between solving our X direction and solving our Y direction. So let's go ahead and do that. Let's find time in the X direction here. So I'm going to divide the V naught X over. So I have the 18.4404, and I'm dividing over that time, which was our, dividing over the velocity, 42 meters per second will give me my time. So when we plug that in, we get a time of 0.9, I didn't even solve for it. So I get a time here. I'm then going to plug it in over here into the Y direction. So I want to pick an equation without V final. So I get Y is equal to Y naught plus V naught YT plus 1/2 AYT squared. Cross anything out that's 0. And we're solving for our Y naught value here. So our Y naught value is going to be negative 1/2, because I moved this over to the other side, so it became negative, times negative 9.8 times our time, which was this 18.4404 divided by 42 squared. Plug that all into your calculator, because you didn't really need to find the time in order to do this. You could just substitute in. And we get an initial height of 0.944 meters. So it drops about a meter. Okay, so it drops about that far. And so what they found was, rather than having the pitchers throw like up at an angle and have this arc to it that goes up and then comes back down, they could give the pitcher a little bit of a mound. It would give them some help in getting the ball there, so they don't have to kind of throw it up at an angle to get it there. Okay.